DS Math and Physics. In this channel, we have already given some important mathematics questions. Now we are going to discuss some important questions for 2020 CHSE board. Questions are from physics, 1 mark questions. The dimensional formula for electrical permittivity. The dimensional formula for electrical permittivity. Dimensional formula for electrical permittivity. We know that F is equal to 1 by 4 pi epsilon naught Q1 Q2 upon R square. Then using this formula, we can get 4 pi epsilon 0 is equal to Q1 Q2 by FR square. Therefore, epsilon 0 is equal to Q1 Q2 by 4 pi FR square. Now you can find out the dimension formula as 80 into 80 by MLT minus 2 into R square L square. Q current into time, that is current into time. 4 pi have no dimensional formula. So it is F MLT minus 2 into L square. So answer is A square T4 M inverse L minus 3. That is M inverse L minus 3 T4 A square. This is the dimensional formula for electrical permittivity. Similarly, the dimensional formula for electrical capacity, then electrical capacity, electric flux, magnetic field. These dimensional formulas to be practiced. You have to find out the dimensional formula. This question carries 1 mark. This is an important question for 2020 board. Next question is the relationship between the peak value, virtual value, peak value and virtual value of AC. Peak value and virtual value of AC. The relation and the numerical related to it. Sometimes the peak value is given, then find out the virtual value. We know the formula that virtual value of AC is E virtual is equal to E0 upon root 2. Therefore, E0 can be found to be EB into root 2. If we know the value of E0, then we can calculate E virtual. If we know the value of E virtual, then we can calculate the value of E0. These things should be concentrated more to find out the relation between peak value as well as virtual value of AC. This is a question which is important from the point of view exam point of view. Now, what happens to the resistivity of a metallic conductor if it is halved? Resistivity of a metallic conductor. What happens to the resistivity of a metallic conductor if it is halved? That means if the metallic conductor gets halved, then the metallic conductor will not change into other material. If a metallic conductor, suppose a copper metallic conductor is copper, made of copper. If it is divided into 2 parts or it is divided into 4 parts, then we will find that the copper will not change into iron or some other material. That's why the resistivity will remain constant, because the resistivity as well as conductivity, not only resistivity as well as conductivity of a metallic conductor will remain constant, and it is independent to the dimensions. It may be half, it may be 4 times, it may be whatever it may be, the metallic conductor, the resistivity of metallic conductor will remain constant. only the factor which is temperature. If increase in the temperature, then resistivity of the metallic conductor will increase. Otherwise, the resistivity will not be affected. Question number 4. Let us have a question. What is the band gap? Band gap. Is the band gap maximum in dash? Band gap is maximum in dash. It is purely theoretical question. Band gap is maximum in insulators. In conductor, the band gap is less, and in semiconductor, the band gap lies in between. In case of the semiconductor, the band gap lies in between the exactly in between the valence band as well as conduction band. The band gap is maximum in dash. In insulators. In insulators. In the process of modulation, dash is modulated. In the process of modulation, dash is modulated. What the question? In the process of modulation, dash is modulated. Answer is audio signal is to be modulated. Audio signal is modulated. The modulation is of related questions are what type of modulations are there? There are AM as well as FM, amplitude modulation as well as frequency modulation, which is for the modulation of audio signal in the TV transmission, AM as well as FM. And what is modulation? That adding a carrier wave with audio signal to be transmitted. Audio signal to be transmitted is called modulation, and the wave which is obtained is called modulated wave. After modulation, if that carrier wave will be separated, then the process is called demodulation. Demodulation is also called detection. I am giving the questions and the related questions with it. In the process of modulation, dash is modulated. We will take another question. That what is the relation between the radioactive samples, the number of atoms in the radioactive samples, and how many half-lives has been carried out? There is a formula which is n equal to n0 by 2 to the power of n. N equal to n0 by 2 to the power of n. If the amount of substance which is left after the radioactive decay is 1 by 32 of the initial value, then how many half-lives will be there? 1 by 32 n0 is equal to n0 upon 2 to the power of n. N0 will be cancelled. So 2 to the power n is equal to 32. That is 2 to the power 5. The number of half-lives is equal to 5. Formula: number of half-lives n equal to n0 by 2 to the power of n. Then related question is, what is half-life period? It is the time taken by the radioactive substance to decay to half of its present value. What is the relation between the half-life as well as average life? Half-life and average life. T average equal to 1.44 into T half. Then what is decay constant? What is the relation between decay constant and T average? That is T half equal to 0.693 by lambda. The relation decay constant and T half life. T half is equal to 0.693 by lambda. These three relations are important. that what is the relation between half life, average life, decay constant, etc. etc. Question number 6. Draw the circuit symbol of input and not a NOR gate, nor a NAND. This gates, input gate, as well as the circuit symbol and their table. Okay. Question number 6. Question number 7. These questions are to be emphasized, and other questions will also be practiced, but these are the important questions actually. Question number 7. Write the SI unit of magnetic field. B stands for magnetic field, magnetic flux phi, and the magnetic field induction is same as that of magnetic field intensity. Magnetic field induction is same as that of magnetic field intensity. So my question is, write the SI unit of B and phi. B, the magnetic field which is expressed in the term as Tesla, and the magnetic flux which is in terms of Maxwell. There is a relation that phi is equal to B into A, that is Tesla into meter square, which is nothing but Maxwell. It is Tesla and this is Weber. So Tesla into meter square equal to Weber. 1 Weber 10 to the power 8 Maxwell, 1 Tesla 10 to the power 4 Gauss. 1 Tesla equal to 10 to the power 4 Gauss. Write the SI units of B and phi, as well as the related questions are like this. Relation between B, phi, A, and the relations and the units. Question number 8. What are isotones from the following species? From the following. Certain nucleus are there, like 7 and 14, then 8O15, 6C12, 8O16. These are the nuclei. We have to find out what are isotones. Isotones are those nucleus in which the number of neutrons remains constant, whereas the atomic number as well as mass number are different from each other. So in this way, we can say that these two are isotones. 7 and 14, 8 or 15, because of there are certain number of neutrons. 14 minus 7, number of neutrons equal to mass number minus atomic number. Mass number minus atomic number. So there are 7 neutrons. So these are the isotones. Question number 9. Power of a lens. Question related to power of a lens and its unit. Power of a lens and its unit. What is the power of a lens? It is the reciprocal of focal length, where F is in meter. Pause the video to note it down. Question number 10. Strength of photoelectric current, relation between strength of photoelectric current, relation between strength of photoelectric current and intensity, current and intensity. Well, the strength of photoelectric current is directly proportional to electric field, directly proportional to the intensity of light radiation. Strength of photoelectric current is directly proportional to intensity of light radiation. The relation between strength of electric current and the stopping potential also. And the frequency of incident light radiation with stopping potential. These relations should be frequency of incident radiation and stopping potential. Radiation and stopping potential. These are the related questions, linked questions. The relations. Question number 11. A relation between IP and EP, between IP and EP of a vacuum diode, not a vacuum diode, it is vacuum of a diode. That is, IP is directly proportional to EP to the power 3 by 2. It is also called 3/2 power law, or it is also called Child-Lindbergh law, Child's law. But IP is the plate current, EP is the plate potential. Some questions I am going to discuss, and some questions you have to find it out. Because of there is very limited time for me. This is my first video on physics, and the next videos we will get also some important questions. The relation between IP and EP of a diode, that is IP is directly proportional to EP to the power 3 by 2. Then draw the truth table for 2 input OR gate, NOT gate, NAND gate also. Then the relation between the transistor parameters. Relation between transistor parameters. Alpha, beta, the derivation as well as the relation. Relation between the transistor parameters like alpha, beta and gamma. What is the relation between emitter current, base current and collector current? Relation between emitter current, base current and collector current. Relation is IE is equal to IB plus IC. Relation between IE, IB and IC. Question number 15. Write the ray diagram for a compound microscope. Ray diagram for a compound microscope. Ray diagram for a compound microscope. Relation between amplitude and intensity. The relation is Imax by Imin is equal to A1 plus A2 whole square by A1 minus A2 whole square. Imax by Imin relation. Imax by I mean A1 plus A2 whole square by A1 minus A2 whole square. Imax by I mean. A1 plus A2 whole square by A1 minus A2 whole square. If the ratio of amplitudes are given, then we can use this one, ratio of amplitude, and from the ratio of amplitude we can find out the ratio of maximum as well as minimum intensity. This also an important question. The force acting on a conductor placed in the magnetic field, moving in the magnetic field, F equal to BQB sin theta. The force acting on a conductor moving in the magnetic field, F is equal to BIL sin theta. And force acting on the conductor, F equal to BIL sin theta. Whereas L is equal to length of the conductor. I, the strength of current. I, the strength of current. F, the force acting on the conductor. On this basis, we have found out F equal to QBV sin theta. Related problem. F equal to QBV sin theta, and for a cyclotron, QBV sin theta. QBV is equal to MB square by R. It is for cyclotron related questions. Then, I think question number 16. Question numbers 17, 18, 19. What are the question numbers? I think 18 or something like that. Characteristics of nuclear force. Characteristics of nuclear force. Question number 18. Characteristics of nuclear force. Question number 19. The question is relation between F, U and magnification M. Relation between F, U, M and F, V, M. When for magnification, F focal length, U for object distance, V image distance. Relation between F, U, M, F, V and M. Question number 20. Question number 20. Binding energy for nuclear. Binding energy for nuclear of 20 Ca40. For this, you must know that what is the mass of the proton in AMU, that is 1.007825 AMU. Mass of neutron, let us take 1.008665 AMU. What is the binding energy for nuclear of this one? The binding energy for nuclear, binding energy Be is equal to 20 into mass of proton, because there are 20 protons as well as 20 neutrons. 40 minus 20, 20 neutrons, minus 40 into 931 mega electron volt. This is the binding energy. And the binding energy for nuclear, binding energy per nucleon. That is Be divided by 40. These are the 20 most important questions for 2020. Thanks. Next, the long questions will be published, will be given in the next video. Watch, share, and like and enjoy it.